Okay, let's look at the answers for example 1. As mentioned, we have a molecule with both bromine and chlorine atoms, and the MZ values are given to you as 128, 130, 132. So this MZ is the M peak, 130 will be the M plus 2 peak, and 132 will be the M plus 4 peak. Okay, so first we are going to identify what are the combinations of isotopes that lead to these respective MZ values. So firstly, for MZ of 128, it means that both of the halogen atoms in this molecule must be the lighter isotope, which means chlorine 35 and bromine 79. For 130, there are actually two cases. The first case is chlorine 35 with bromine 81. Second case is chlorine 37 with bromine 79. And for the MZ of 132, the only possible situation is you have chlorine 37 with bromine 81. So knowing this, I can use this to then write the identity of the ion. So please specify the isotope that you are referring to when you write the ion. Okay, and the relative abundance will be the probability of this isotope multiplied by the probability of this isotope, which will be half times 3/4, which will give you 3/8. Okay, so for MZ of 130, there are two possible ions. So we need to find the individual probabilities and then add the two probabilities together. So for 79 and 37, half is the probability of bromine 79, 1/4 is the probability of bromine 37. So multiply, and then half for bromine 81 and 3/4 for bromine 35. Again, multiply, add up. Probability here is 4/8. And lastly, for MZ132, the only situation is bromine 81 and chlorine 37. So the probability here is half times 1/4, which will give you 1/8. So the conclusion we can draw is that if I have a compound that has one bromine and one chlorine atom, the ratio of intensities of the M peak to the M plus 2 peak to the M plus 4 peak will be 3:4:1.